The honeymoon phase of AI is ending, and enterprise leaders are moving beyond proof of concepts and grappling with a harsh new reality. What does it actually cost to scale AI? And today, we're going to get into the nitty gritty economics with someone who's been wrestling with these decisions at massive scale. Is Sam Hamilton. He's Senior Vice President of Data and AI at Visa, a company that processes payments across 200 plus countries where millisecond delays can mean millions in lost revenue. Sam, help me understand the scale of what we're talking about.
I would say 11 billion endpoints. When it comes to the AI solution, we utilize more than 400 AI solutions, incorporating over 300 AI models, and that leverages hundreds of petabytes of data. Our system, that's a payment processing system, processes over 630 million transactions per day with processing time measured in milliseconds, with each transaction involving multiple AI inferencing steps. That's the scale we are talking about. Our team has over 2,500 technologists dedicated to build data and AI platform and associated services. And Visa has invested more than 3.5 billion in data and AI infrastructure alone for the past 10 years.
Were there hidden costs that blindsided you that other enterprise leaders should be aware of or budget for upfront?
GPU parts or in AI infrastructure comes to our mind, top of our minds, and that's important. Besides that, I would add few more things. Getting the data ready for AI. That's where the data management, labeling, and high quality data set that you are doing that and consuming that in a timely fashion, and especially the sensitive fields that you have in your data system need to be careful. The model is not built once, done with it. The modern way of building the models allows us to be changing along the way. So we need to make sure there is no drift, there is no bias, there is no failure, and we need a human oversight. So the model maintenance cost needs to be in place. Every company that's probably in bringing in AI new may already have a traditional or legacy systems. That's a cost involved in integrating with them.
You mentioned you need millisecond response times for use cases like fraud detection. Um, Walk me through how cost economics shape those infrastructure decisions. What trade offs did you have to make to hit those performance targets within a budget?
Sure, that's a good question, and we have been developing an optimized technology stack for many years now, and we have brought in many innovation and also investing in high performance infrastructure. And we do a smart integration of the processing systems, AI platform, and data systems. That gives us a tight integration where we can get not only low latency, high performance, but also the cost efficiency. And if you look at our process, we pick the best algorithm and optimized for both performance or latency at the same time. And where we can employ even AI to figure out what computation need to be done ahead of time to get the latency that we need to get. And of course, we work very closely with our infrastructure partners to use scalable and cost-effective solutions.
It seems like there's always a tension between wanting the latest and greatest, most capable AI models and controlling costs, especially long term costs. How do you balance that pressure for cutting edge innovation against budget sustainability at Visa?
That's a very popular question. And the principle is simple: pick the right model for your application. And we have developed a platform designed to facilitate the consumption of multiple generative AI models called as an LLM or any other foundation model. That platform, we call it as Gen AI platform. This platform has the capabilities to host multiple generative AI models to choose from. And it has a built-in cybersecurity and DLP through our service called AI Guard that scans every input that goes in, output comes out of that to make sure that we have the right data going in and out. And also out of the box, this platform provides RAG, retrieval augmented generation, machine learning capabilities, and model context protocol (MCPs) and agent frameworks to make it easier for the applications to build Gen AI and capabilities very quickly. And also, this platform allows the developers to test and use the best model that suits their application.
Fantastic. And that I really want to ask about your compute infrastructure. We have a growing myriad of GPU, CPU, custom accelerator choices. How do cost considerations drive those hardware choices? Are you primarily building in the cloud or are you buying your own infrastructure? And what's the economic calculus between performance and price there?
We do both. We are a hybrid. We have both on prem and cloud. Maybe I should talk about the infrastructure evaluation criteria that we would use, which starts with the total cost of ownership. It's not about what we are paying now, what is going to be the total cost of ownership. And we can think of that obviously in a couple of different ways: performance per dollar, uh, T-flops per dollar, and how many trillions of floating point operations per second that we can get out of that hardware. That is important for us. And also the operational cost, dollar per inference training epoch is important for us as well. So this comes to the cost part of it. And it's not just about the cost. We want to avoid vendor lock-in. Of course, the scalability and utilization is important. And on top bringing up the utilization, that's where we decide whether we want to do that on-prem or the cloud. So you asked about the CPU, GPU, and custom accelerators. All of them have a place in the ecosystem, if you would. And CPUs, we typically use them when it's kind of a general purpose. We need to have a lot of flexibility and relatively inexpensive per unit. If you think about that, get started on that quickly, either on-prem or in the cloud. And but it's not typically good for highly parallel task, or if you want to put a deep learning model into that, that may not be a good uh, compute infrastructure. Then comes to GPU, and it's a great for the parallel workload. This is where they train the large models, and also it could be expensive in terms of power, cooling, upfront cost. And this is where we can look at that whether we wanted to bring in a GPU on-prem or we wanted to use that in the cloud. When it's a hardware level, so TPU, FPGA, ASICs. Category number two would be open source model. We take the model where we can fine tune them for a specific use. Category number three is that's where we use the proprietary models.
Are there any hidden costs in any of those three approaches that you've discovered so far?
Yeah, look, definitely there is factor that we would, the kind of a framework that we use that talks about the upfront cost for those model, customization cost that's for the model, operational complexity that results in cost, and what's going to be the long-term cost, what is the support cost for the SLA that we need to have, and what are the control that we have that that specifically for the data that goes into building those models. Those were the criteria that we use. So if you take an example of an open source model, there is upfront cost is low to none. You can take an open source and start building those, and but the customization cost is going to be really high, and operational complexity depends on the use. It could be really high as well, and the long term cost typically lower if you're looking at that to be 3 to 5 years if you were. But in the AI space, we are looking at 6 months to 18 months, not necessarily. So now you asked about the hidden cost. For the hidden cost for the open source model, when we use them, definitely there is an engineering cost. Now you have your own team, need to be fine tuning that and may be able to change things around and should be able to understand really well both your business and also the model that you have, like so they can bring the bridge to that. And compute cost. Now you're fine tuning. You need to have your own infrastructure in place to fine tune and also to run that as for inferencing. And of course, we talked about the in house expertise. That's where the talent comes in. and security and compliance to make sure that you are building that with the security and compliance. Nobody else is going to vouch for it. You need to do that yourself. So that's the hidden cost of the open source. When it comes to the proprietary, it's slightly different, and it's typically a usage-based pricing. That's what you would see, and we need to be careful about the vendor lock-in, and unless we are bringing in something what we have built as a Gen AI platform to provide an interface there. And it typically with the proprietary models, very limited customization that you'll be able to do or fine tuning. Even if you do, it's going to be really, really expensive.
You mentioned earlier that these systems aren't exactly static, right? There's a constant care and feeding and maintenance that goes into keeping the system performant and accurate. Are you tracking those costs of maintenance as a standalone KPI yet?
That goes into part of the total cost of ownership. That, as we said, it's a software when we build them. The cost of maintenance is when we need to do the bug fixes or when we need to do the enhancements. Whereas in the model, you need to be constantly monitoring that. That's one of the principles that we have as part of the responsible AI. And that's the nature of the model, how it works. It could be model drift, it could be bias, and it could be fairness that you need to be checking that. And if it start drifting, it could drift very fast. So that we have what we have built, what's called the AI observatory, that we can continually monitor how the model is performing. Is it within the limits of what is allowed? So there's a cost associated with it as well. And if you find something deviating, we need to make sure that it is being done. So the model maintenance and monitoring is really critical. That adds to the total cost of ownership of it.
I just want to say thanks so much for coming today and sharing your insights with me and the rest of the VentureBeat audience. Thank you, Sam.
Thank you so much. It's a privilege to be here. Thank you. I appreciate the tips.
And thank you for watching. For more stories about the impact of AI and the forces reshaping enterprise, sign up for our newsletters and check out more videos at venturebeat.com.